In commercial shrimp and fish farming, a single invisible variable dictates the success or failure of an entire harvest. This chart shows how feed dominates farm overhead, representing 60 to 70% of the total operating budget. Hovering over these massive investments are severe biological threats. These pathogens thrive in high-density environments. Once introduced, they can wipe out entire ponds, destroying a farm's annual margins in a matter of days. Because feed dictates water quality, animal immunity, and growth rates, feed management is the primary vector for commercial farm survival. For decades, the industry relied on a standard playbook, sourcing cheap feeds held together by synthetic binders like PMC, a urea formaldehyde resin, and treating ponds with reactive antibiotics only after diseases appeared. Aquatic pathogens adapt rapidly. Decades of chemical treatments have resulted in severe antibiotic resistance, rendering the old reactive treatments useless. Furthermore, international export markets in the US and EU, alongside certification bodies like ASC and BAP, now strictly ban chemical and antibiotic residues. The modern alternative is bio-optimized feed. These are diets engineered with plant-based phytoproteins, live probiotics, and organic binders. These formulations require a massive upfront premium. The dilemma for a farmer operating on razor-thin margins is whether paying for herbal and organic feeds actually results in a mathematically more profitable harvest. Unlike fish, Litopenaeus phanae, the white-leg shrimp, are slow bottom feeders. They grab food with their claws and masticate it outside their mouths before swallowing. Because of this feeding behavior, feed pellets must remain structurally stable in water for up to 3 hours without falling apart. Conventional synthetic binders leave toxic formaldehyde residues. Modern organic binders, such as Intact Aqua or EasyBind, use naturally derived compounds to achieve the same structural hold. The hidden cost of cheap binders is rapid nutrient leaching. When pellets dissolve too fast, expensive proteins disperse before shrimp can eat them. This organic matter causes severe turbidity, blocking light and directly triggering oxygen depletion, animal stress, and disease outbreaks. Organic binders create a safe, hydrophobic barrier that locks nutrients inside the pellet without poisoning the surrounding water. Paying a premium for an organic binder is a direct cost-saving measure. It prevents expensive feed investments from turning into toxic pond sludge. Once the water environment is secured, the next operational priority is defending the stock against mass mortality events. Instead of reactive antibiotics, the bio-optimized strategy uses daily immune priming. This involves feeding the shrimp plant-derived immune modulators like andrographololide or Spiromax PS. High-density environments cause physiological stress in shrimp. This stress leads to the overproduction of reactive oxygen species, or ROS. These are highly unstable molecules that aggressively strip electrons from healthy cells. Unchecked, ROS damages DNA and tissue, triggering the exact cellular inflammation that precedes mass die-offs. The flavonoids and antioxidants in premium feed act as scavengers. They actively neutralize ROS and boost hemocyte phagocytosis, the biological process where immune cells consume and destroy invading pathogens. Premium bio-optimized feed functions as a daily biological insurance policy. It neutralizes internal threats long before they require an expensive, export-ruining antibiotic intervention. These functional, bio-optimized feeds carry a significantly higher cost per kilo than traditional alternatives. However, the only metric that determines true profitability is the feed conversion ratio, or FCR. This is the exact number of kilos of feed it takes to grow 1 kilo of shrimp. Live probiotic blends actively break down complex plant proteins for maximum absorption, driving digestive efficiency. Field data shows these diets yield up to 25% heavier harvests and shorten the cultivation cycle from 120 days down to 90 days. Because the shrimp absorb more nutrients and grow faster, the total volume of feed required drops. Bio-optimized feed lowers the true cost of production. This nutritional baseline must be established early, starting in the hatchery and nursery stages. Post-larvae face immense physiological stress when they are transferred from controlled hatcheries to volatile grow-out ponds. Feeding premium microdiets enriched with yeast extracts, specifically beta-glucans, primes the innate immune system of the larvae before they ever touch the pond water. Investing heavily in hatchery nutrition creates a foundation of highly robust, stress-resistant animals. This protects the grow-out farmer from devastating early mortality rates. Modern aquaculture requires transitioning from treating sickness to funding wellness. This transition isn't mathematically viable for every farm. For low-density systems serving local markets, paying zero premium for chemical-free shrimp, functional feed costs outweigh returns. But for commercial high-density Lidopaneus vannamei farmers or operations targeting US and EU exports, full bio-optimized integration is mandatory. For commercial-scale operations, relying on cheap feed and reactive chemicals is a guaranteed path to diminishing returns and locked-out markets. The most expensive feed a farmer can buy is the cheap feed that dissolves rapidly, spikes pond ammonia, and leaves animals vulnerable to Vibrio. Bio-optimized plant-based nutrition has evolved into the standard tool for ensuring commercial yield and market access. In the modern, highly regulated aquaculture landscape, bio-optimization is the uncompromising baseline for commercial survival, ecological sustainability, and maximum profitability.